Welcome back, Science 10. This is D 3.2, International Collaboration on Climate Change. So in the CD1 section, this looks at what are we doing as a world to help combat climate change. So since climate change could have many consequences, the world scientists, governments, and the citizens have agreed to act now on human actions that contribute to climate change. So yes, looking at, okay, what could we do now? Will humans contribute to climate change through a global warming, greenhouse gas contributions, so what could we do? As you've seen in previous sections in this unit, the problem of climate change is complex and not yet fully understood, so it is a challenge just to decide what to do first. Because climate change is a global issue, the political, environmental, and social issues involved can sometimes make actions difficult, because all countries must come together and decide on a plan of action. So, scientific collaboration on climate change. Scientists gather more data and learn more about climate. The confidence level of their predictions increases. Climate research depends on international cooperation, as I mentioned. In order to do the best possible job, scientists must share climate data with other countries and access to the tools to collect and analyze data. So that's the big thing. All countries must be willing to share their information that they've collected and come together to find potential outcomes and ways of dealing with it. A recent IPCC report on climate stated that the confidence in the ability of models to project future climate has increased due to the sharing of information. Advances in technology have also contributed to the increased confidence level. For example, scientists have achieved a better understanding of how water vapor and other greenhouse gases affect global climate. So we saw that earlier. Better computers and software have given us computer simulations and models that can analyze and more accurately predict the effect on human activities, such as the emission of more carbon dioxide into the atmosphere. There are a number of different types of computer models of climate, but the one that reflects the observed climate data of most climates is referred to as the General Circulation Model, or GCM for short. These highly sophisticated models incorporate laws of physics to model climate on a global scale. GCMs center on the effects of changes that affect the Earth's energy balance. So for example, changes in insolation, albedo, and or absorption, on thermal energy transfer in the atmosphere. Since climate modeling is very expensive, scientists must pool the resources to use this technology to the best of our advantage. So again, collaboration internationally, sharing equipment, sharing resources, etc. Since GCMs reflect the world's climate the best, it may seem that climate modeling should be done using this type of model. When choosing which model to use, scientists consider the problem they are investigating, the type of data that are available. In some cases, other models will produce a result with a higher level of confidence than will GCMs. Predictions made by climate models can also be good as the data which the model is based on. So satellites, high-altitude jets, deep-sea submarines, we have all those now. And of course, we can look at areas that previously we couldn't look at before. So the deep-sea submarines, we can go down the ocean bottoms. Satellites, we can see down and using infrared, look at what's happening in terms of temperature globally. The type and quantities of gases and dust in the Earth's atmosphere can be measured accurately because of improvements in science and scientific instruments. Nations must also share this data in order to get an accurate picture of climatic events. Okay, so the big thing there is looking at cooperation. Okay, we'll skip to here. Political collaboration on climate change. As our understanding of global energy systems improves, the challenge becomes one of ensuring international cooperation to reduce the contribution of human activity to global warming. The Government of Canada has entered into several agreements with other nations to make changes that will benefit the atmosphere and alter Canada's contribution to climate change. So the first one we'll look at here is referred to as the Montreal Protocol. It's an international agreement to phase out the production and use of CFCs and was the first international agreement concerning Earth's atmosphere. So it's an action plan looking at getting rid of CFCs, chlorofluorocarbons, as we looked at earlier. It was signed in 1987 by 182 nations, including Canada. CFCs were invented in 1946 to replace flammable and toxic compounds formerly used in industry. And of course, As we've looked at earlier, they were used in aerosol cans, fire extinguishers, and air conditioners. In the 1970s, chemists Mario Molina and F. Sherwood Rowland showed that CFCs react with the ozone in the atmosphere, converting it into oxygen. Even a very small amount of CFCs can cause a significant loss of ozone layer. CFC emissions are thought to be the main cause of the thinning ozone layer that has been observed over Antarctica and other regions. And of course, with the, you remember this from earlier science classes, ozone absorbs much of the UV radiation that comes from the sun. So if we lose ozone, that results in more UV radiation reaching us, which could lead to a net radiation budget increase on areas of Earth and cause an increase in global average temperature. And of course, it could also cause other things such as increasing rates of skin cancer due to be exposed to more ultraviolet UV radiation than normally. Hydrochlorofluorocarbons, HCFCs, are chemicals with similar properties to CFCs, but they destroy the ozone much more slowly. The Montreal Protocol specifies that nations ban the use of CFCs and replace them with these other ones, HCFCs, over a specified time area. It's only a temporary solution to ozone depletion because it just simply takes much slower to react. And if we look here, the Canadian government plans to ban HCFCs by 2020 and hopefully find something else that we could use instead of that. United Nations Framework Convention on Climate Change, or UNFCCC, is an agreement by the world's nations to act to stabilize greenhouse gas emissions caused by human activity. So this one looked at CFCs. This one's looking at, okay, what can we do to stabilize, to slow down the release of greenhouse gases, possibly have a balance, as we've seen before. So it's not an action plan. Instead, it sets out a process for making international agreements on future actions related to climate change. So in the future, how can we make a balance between carbon sources and carbon sinks? What can be done in the future? The UNFCCC marked the first time the world community acknowledged that human activities could be causing climate change. All right. The nations that signed also agreed that any actions to stabilize greenhouse gases emissions must not threaten global food production or the economic interest of any nation, and must support sustainable development. Sustainable development is the use of the world's resources in ways that maintain these resources for future generations with minimal environmental impact. So looking at the future, what we're doing today, how will it affect future generations? So that must be considered as well. For example, to meet the standard, the forestry industry in Canada must harvest our forests in a manner that ensures the total amount of forest cover does not decrease. Photosynthesis by forest is a carbon sink, as we mentioned earlier, that removes large quantities of carbon dioxide from the atmosphere, plays an important role in stabilizing greenhouse gases. Forests also provide habitat for many wildlife species, recreation, etc. These roles, along with economic importance of forestry, must be considered. Okay? The Kyoto Protocol on Climate Change. This was an international agreement to reduce the production of greenhouse gases. In 1998, Canada and 160 other countries agreed in principle to set a goal of 5% reduction in global greenhouse gas emissions by 2012. According to the Kyoto Protocol, Canada must reduce its emission of greenhouse gases to 6% below 1990 levels. And the figure down below illustrates that. So if we look down here, this was our CO2 emissions in Canada. So in 1990, if we look here, 600 megatons of CO2 emissions, and you can see gradually increased, and if the trend here, you can see what happens. So the Kyoto Protocol suggested that we reduce such that when we reach 2010, we're below what we would have generated in 1990. Okay? So that's what that graph illustrates. Instead of continuing with the upward trend, do things to reduce it to below 1990 levels. Okay, we'll stop there and we'll look at the remaining part in part 2. See you soon.